Hello everyone, it's LMTX. Today I will talk about AWS services typically used in IoT projects. I will cover the consumer Internet of Things and industrial Internet of Things, so I hope you will find this interesting. Let's start with brief characteristics of consumer and industrial IoT solutions. The consumer IoT products and services are designed for consumer, so the end user is typically a physical person. It's a very versatile space. ciot product might be a simple single device connected to the internet or a complete smart home appliance that consists of multiple interconnected devices. On the other hand, the industrial IoT is aimed at the business market, where the end user is typically an enterprise. We work with many interconnected devices. Most of the time, industrial IoT covers the processing and machine learning at the edge and machine-to-machine communication. We commonly work at the intersection of information technology, IT, and operational technology, OT. Let's review AWS services frequently used in consumer IoT deployments. IoT initiatives are very versatile and can use virtually every service offered by AWS. Please be aware that presented list of services is just an example based on my experience, and this is not an extensive list. This is a sample ciot architecture. The IoT core is the main AWS service used in IoT initiatives. It provides the Think registry, credentials management, and MQTT connectivity, essential features needed to establish communication between devices and AWS cloud. Once message from IoT device is received, it can be processed using rules to perform automated actions. For example, messages containing device configuration and metadata can be stored in DynamoDB, while telemetry data is frequently stored in TimeStream database. Speaking about databases, using DynamoDB and TimeStream allows for serverless approach. Our solution will scale automatically to handle current load without any changes in deployed infrastructure. Sometimes we need to decode message payload before it can be processed. In that case, I recommend using the Kinesis Firehose. It can buffer messages based on size or time interval and invoke Lambda function to do required processing before storing data. For instance, in the S3 bucket. Once we have data in the S3 bucket, we can analyze it in many different ways. IoT consultant is responsible for data ingest. Data processing is typically done by the data science team. It's very important to enable the IoT core logs. So events like connect, disconnect, and shadow operations can be recorded in the CloudWatch log group. This data will be extremely helpful during troubleshooting of connectivity issues and authorization failures. In ciot deployment, we are typically working with huge fleet of devices. That is why I recommend using the Device Defender to monitor security posture of your system. Device Defender can verify the quality of certificate key and send SMS notification when device certificate is going to expire. We can also configure the Device Defender to detect these shared credentials of IoT devices. You should never use the same set of credentials for multiple IoT devices. When Device Defender detects that some devices are sharing credentials, it should be handled as a security incident. Device Defender should send a message on a specified SNS topic to trigger Lambda function for automated mitigation. ciot devices are not always online. Sometimes they operate in environment with unstable network access. In those cases, you should use the device shadow functionality. This way, your backend application can read and set device parameter, even if device is offline. Once device gets back online, it will synchronize its state to match the device shadow. ciot devices are usually used together with web or mobile application. For instance, to manage device or review dashboards. I recommend using the AWS Amplify to develop those applications. It supports major web frameworks and native Android and iOS applications. AWS Amplify accelerates the front-end development and integration with backend services. In order to set up and manage your AWS infrastructure, you should use the CloudFormation or AWS Serverless Application Model, SAM, which extends the CloudFormation capabilities and allows for faster development. You should avoid doing changes from AWS console when working with production system. Manual changes are error-prone and hard to track, and hard to roll back if needed. To automate deployment, I recommend using the code pipeline services, the build and deploy. I hope this overview of AWS services frequently used in ciot was interesting for you. Once again, that is just a sample setup. It's not extensive list of AWS services that can be used in consumer IoT projects. Now let's move to AWS services frequently used in the industrial IoT deployments. Let's review a sample IIoT architecture. We covered some of AWS services already. After all, the consumer IoT and industrial IoT use mostly the same technology under the hood. There are some major differences between ciot and IIoT I would like to talk about. The most important factor is that we usually have more control over the edge infrastructure in industrial IoT than in consumer IoT. Industrial network setup is more complex than in consumer IoT. Shop floor level devices usually do not have access to the public internet and can communicate only with internal systems. All outbound traffic goes through proxy, which limits the endpoints that can be reached. Sometimes factory owners allow to use only specific AWS services and blocks access to the rest of them. Those restrictions are very important and should be taken into account during the design phase. Additionally, factories are using the very restrictive firewalls that blocks all incoming connections and limits allowed ports. Our solution should be designed to operate within those constraints. Recently, AWS IoT Core introduced support for the VPC endpoints. That feature is very important from design perspective. It allowed to span the private network between factory and AWS infrastructure. This way, only private IPs are used during the communication. Many factories are using the Direct Connect service, a dedicated connection from on-premise network to AWS infrastructure. This way, data never goes through the public internet, which increases the security of data in transit and ensures stable connection latency. In IIoT deployments, we not only manage the cloud infrastructure, but also the on-premise systems, typically edge gateway servers. In order to manage the edge gateway servers behind very restrictive firewalls and proxies, we use the Systems Manager. During the initial setup, the local administration installs the SSM agent on the edge gateway using generated hybrid activation code. Once instance is registered in Systems Manager, further OS level configuration and application management can be executed remotely. I recommend automate all edge gateway configuration changes and setup. It can be achieved in many different ways. Personally, I recommend Ansible. SSM agent can execute Ansible playbooks locally on the managed instance. Greengrass service is typically used to execute processing at the edge. It can communicate with OPC-UA servers and internal databases to gather shop floor data. Secrets Manager should be used to store and manage credentials for external systems. Use the Systems Manager component to deploy secrets from AWS Secrets Manager to Greengrass Core in a secure way. You can create a custom Greengrass component to host a local dashboard or web interface directly on the Edge Gateway server. This way, those applications will be available only on the internal network, which limits the potential attack surface. Greengrass components can be deployed and managed remotely, even operating behind restrictive firewalls. Developers can build components in the dev environment, then deploy them to the production once ready. Industrial customers typically prefer to control the root certificate authority, the root of trust within the organization. AWS Certificate Manager can be used to manage the subordinate CA and issue certificates using the established chain of trust. This way, we can automate device registration and certificate rotation process while using the third-party certificate authority. Sitewise is a dedicated service to collect and manage data from industrial equipment. It allows to easily model physical assets and compute the common industrial performance metrics. You can use it to group sensor data from multiple production lines and present it on a dedicated portal using the site-wise monitor. So let's summarize what we covered. Consumer IoT is focused on the end user. That's a person. That person has full access to the owned IoT device. Industrial IoT is focused on the enterprise, and our solution should operate within the enterprise ecosystem. IoT system should be secure by design. We should not make the end user responsible for that. Serverless approach enables scalability, so always try to design your system in this way. If this presentation was interesting for you, you can get slides and diagrams from the thinkrex.com/services. Thank you for watching and all the best, LMTX.